Welcome to my maths class. In this class, we'll solve sums from NCERT textbook, class 9, chapter 5. I am up and down and round and round. End of chapter exercises. Question number 12. It's on page number 115. The sum says, when two chords intersect each other, each of them is divided into two line segments. Show that if the intersecting chords are of equal length, then the line segments of one chord are equal to the corresponding line segments of the other chord. So here there are two equal chords. AB and CD are two equal chords. They are intersecting at point E. So when they intersect, the chord is divided into two parts, two line segments, AE and BE. Two line segments, it means cut into two line segments. Here also, chord CD is cut into two parts, CE and DE. We have to show that if AB and CD are equal, then the line segments of AB, that is we have to show that AE is equal to CE and BE is equal to DE. We have to show that AE is equal to CE, BE is equal to DE. Now, O is the center of the circle. First, we'll write what is given to us. Given. O is the center of the circle. O is the center of the circle. Chord AB and chord CD intersect at E, and AB is equal to CD. This is given to us. And what we need to prove? We need to prove that we need to prove that AE is equal to CE. AE is equal to CE and BE equal to DE. BE is equal to DE. So to prove this, we have to do some construction. So the construction, that we will do is draw OM perpendicular to AB and ON perpendicular to CD. Then join OE. We have to draw OM perpendicular to AB and ON perpendicular to CD. Then we have to join OE. So we have drawn the construction. OM we have drawn perpendicular to AB and ON is perpendicular to CD. And we have joined OE. Now we will go for the proof. So here first we will try to prove that OM is equal to ON. First we will try to prove OM equal to ON. Now AB is equal to CD. The chords are equal, that is given to us. OM is perpendicular to AB and ON is perpendicular to CD from construction. So OM is equal to ON because we got a theorem. The theorem states chords of equal length lie at equal distance from the center. AB and CD are equal. When they are equal, their distance from the center also will be equal. That is, OM will be equal to ON. Chords of equal length lie at equal distance from the center. Till now what we have done? We have proved OM is equal to ON. Next we will take the two triangles and prove them to be congruent. In triangle OEM and triangle OEN. In these two triangles, angle OME is equal to angle ONE, that's equal to 90 degrees, because from construction OM is perpendicular to AB. ON is perpendicular to CD. OE, side OE is equal to side OE. It is common. And OM is equal to ON. We have proved above. We have proved it here. Proved above. Proved above. Therefore, triangle OEM is congruent to triangle OEN according to RHS rule. RHS rule. Right angle, hypotenuse and one side are equal. So they are congruent. So EM is equal to EN. You can see here EM is equal to EN. Why? CPCT. CPCT. Corresponding parts of congruent triangles are equal. So I will name this equation as 1. EM equal to EN. Now, what we will do? We will prove AM equal to CN. We will prove AM equal to CN. Now, OM is perpendicular to AB. From construction, OM is perpendicular to AB. So, OM bisects AB. Bisects AB. There is a theorem that states that the perpendicular from the center of a circle to a chord bisects the chord. Bisects the chord. So when OM cuts AB into two equal parts. So AM will be equal to half of AB. AM equal to half of AB. Now Similarly, Cn also will be half of Cd. Cn will be equal to half of Cd. M is half of AB. Cn is also Cn is half of Cd. We know that AB equal to CD. Given AM is half of AB, Cn is half of CD, and AB is equal to CD. So AM will be equal to Cn. Therefore, AM is equal to Cn. This, I will name this as equation number 2. Now, equation number 1 says Em equal to En, and equation number 2 says Am equal to Cn. So what we will do, we will add both the equations. Adding equation 1 and 2. Equations 1 and 2. So we will get Am plus Em will be equal to Cn plus En. Am plus Em is AE. So AE will be equal to CE. So this equation, so we have proved AE equal to CE. The first part what we had to prove, we have proved it here. Let this statement be equation 3. We have shown AE equal to CE. Now, AB equal to CD. Let this equation be 4. This is given to us. Now what we will do? We will subtract equation 3 from equation 4. Subtract three from 4. AB minus AE will be equal to CD minus CE. So from the drawing, AB minus AE is BE. AB minus AE is BE. You can see here, AB minus AE is BE. In the same way, CD minus CE is DE. So BE is equal to DE. So we have proved what we wanted. We have proved AE equal to CE and BE equal to DE. Hence proved. Hence proved. Please like, share and subscribe. Thank you.